Okay. So what I'm going to do today is let's finish this exercise, the 2B, the one that we have up to the last session. And in fact, for those that might be, I think that all of you have connected before. Do you have the file? Do you have this file? Do you all have the file?
No, would you perhaps be able to put it in the chat if that's all right?
Yeah. Let me do that. If I can, because more, I am not in the full a full Zoom application, the desktop application. I am in the browser. Is any one of you able to share it here? I don't see the, unfortunately, Ro, I don't see the button to share here the file. I think it's because the browser is probably limiting the capabilities.
Would you be able to email me the file and then I can put it in the chat?
Right, yes, let me do that. Okay, it's on your way. Right, so let's do a quick recap of what we did last time. We have this information from an oil well where we have the dates, and the dates have this format of strings, and they are all contained within a list. So we had a look at the type of variables that we had in there. We noticed that everything is within a list. And also we did a couple of things, extra things. One was to plot the information, and we can see that there is an issue here with the access, but this is all customizable, and you can go into the settings of Matplotlib to understand how to customize. And finally, we also applied the Duomet equation in different ways, and we use a for loop with the list, and we ultimately also define a function, and we also use NumPy, and we use NumPy and a function to estimate the rates of a well. So ultimately, what we want to produce at the end is a mix of this plot and this plot. So we want to overlay this plot in order to have something similar here. And what I was asking last time is if you could produce your own plot out of this exercise. So we're going to have, let me now pick it up from this point, and I can simply make a mix of those two plots. But we have an issue here. And if you remember, for those that were connected, in this particular case, we have here in this access time, and in this particular case where we have rates and we have dates, and these dates are a string. So somehow we need to come up with a way in which they both have the same kind of reference point. So either we convert these dates here that we put here to time, where this will be like our time 0 up to this time, or we convert the other times to dates. What I'm going to do is I think it's very important to understand how to convert these dates to, or this string to a date format. And for that, I'm going to use a library called datetime, which is imported here at the top. And it's imported as DT. So what I can do with that datetime, so for instance, if I go to, and actually let me make a copy of this, and I'm going to call it save a copy in Drive.
Sorry, Alejandro. Sorry to cut in. Would you be able to send the file again? I still haven't received it.
Can you check on your junk?
Yes, I can double check.
I'm going to reply to that email that you sent me. Let me.
Oh, I got it. Thank you.
Oh, you're right. Okay, brilliant. Okay. So on this exercise, I'm going to call it solution. And this date, and let me bring it to the bottom here, where I have these results. And if you see the type of that variable date, and obviously this this will run. This I won't be able to run this because I need to go to the top and rerun the whole notebook. Why is that? Because I just have been allocated with a machine within Google Colab, so I have to go back to the top of the notebook and rerun everything. So you can simply go here to the top and then click on Run All, and hopefully everything will be run again. In that sequence. Okay, we're back. So that is a string, and with the library that I imported at the top, I can call this, let's say, date corrected. And let's make sure that we can read that as an actual date. And in order to do that, we can do DT dot, there is a datetime say class where I can use these couple of functions. So this is a string. There are a couple two ways to do it. One way is I can take the string and convert it in date time, and the other way is I can have the date and convert it to a string. So this, we're going to use this one, in which we're going to convert it to date time. And we have to pass a date. I believe if we do that, let's see what's happening. So this takes two arguments, and we have to supply what is the format of that date time. So if you remember the format, so we have to specify how this has to be read. So in which case we have to specify this is year, the month, date, hours, minutes, and seconds. So I'm gonna just copy and paste the format. Okay, and let's see what's happening here. Now that I have run that, I'm going to show you what I have in date corrected. And what I have in date corrected is a datetime format. So why is this important? So can anyone just explain me why am I doing? I'm trying to do this. Anyone has an idea of why I'm trying to convert from a string to this datetime format?
So time series forecast, trying to like convert to time series.
Yes, that is obviously what we want to have the time series. But more than that, I cannot do operations with a string. Let's say you want to have you want to calculate. You have a number of barrels per day that are being produced on this well on a given period of time, and you have those rates, but you want to calculate the volume. So you need to come up with a delta between those times. If I cannot do an operation, so say if I take these dates, which has all these dates here, so I won't be able to do things like date 1 minus date 0. If I try to do that, that would cause a trouble.
Right.
But
yeah, that's right. Yeah.
But if I try to do something like this, where I say dates 1, or we have this date corrected. Let's say this is, let's do it for the whole thing. In fact, I'm going to do a for loop for this date in all the dates. What I would like to do is apply this function. Okay, so I would like to apply this function to every item in the dates, and I'm going to save it in dates underscore corrected. Okay, dates corrected is going to be a list, and that's the way I can initialize an empty list. And if I want to add elements to the list, what I'm doing here, let's call it this element is equal to this, and I can add dates corrected dot append. So every time I go to a new date, I'm going to append this element. Okay, so if I run that and I show you what is dates corrected now, that dates corrected is now for every date I have a datetime feature, and this is very important when you're working with time series, as it was mentioned by Hasir. So you need to make sure that you are converting those strings to datetime. And now I can do things like dates corrected. So I'm going to take my dates corrected 1 minus dates corrected 0. So I am doing an operation, and that is giving me actually a time delta of 30, which is 30 days. Right? So that's the first step. So we are at the moment trying to make trying to convert all those string values to date times. One thing that is important also is if I repeat this plot here, and I put it in here, but now instead of dates, I'm going to make that plot with dates corrected. Look at this. So now Matplotlib is identifying that this axis, it's a datetime, and it's referencing all the dates according to the space of time between the dates. Was that clear?
Yes.
So you see here now, in fact, the previous plot, it was showing all these numbers and all these values. But all these values that you see in here are just a display in orderly fashion of these strings here. I could have put here in the list, I could have put my name, and it would have plot everything in that order. And in the last point, in the last position, it would have plotted my name. Okay? And this is very important, regardless of the domain that you're working. You're going to work with a lot of time data. You're reading from the database, or you're reading from an Excel, and suddenly what you get is a string. And you will have to move data around and play around. And this is one of the things that I really hate the most to do in Python, because usually you open one Excel and you're working in Canada, and you have a particular date, month arrangement, and you move to another country, and you move to the UK, and they have a different date, month arrangement, and it gets quite tricky reading all. Not particularly Excels, because the Excels won't be that much of a trouble, but for instance, CSV files, or even information in databases. So you need to really understand what is the format that the datetime it's specifying the database. So all that is clear. What I'm going to do here, it's because of a time constraint that we have, I'm going to just copy up and paste. Well, let me try to do it. So I'm going to generate a new times list, and as we mentioned before, we have a times list that we created here. And where are they? So we created these times NumPy, but these times are not corresponding to the time that we have in this the particular list. Okay, so one thing that I can do is from these dates corrected, things that I can do, operations that I would be able to do if I take the minimum date. For instance, I can do minimum of dates corrected. I can do minimum of dates corrected, and that will return the minimum date, not the first value, but the minimum date in the array. And that's something that is important as well. Sometimes you receive these days in orderly fashion, and you need to make sure that they are ordered later on. But if you use the date time, it's always going to be ordered. And just for the sake of an example, let me print here that minimum date. And I'm going to have all these times. And again, I'm going to do a loop. So for this date in dates corrected, what I would like to do is have a temporary date that is going to be equal, or actually this is already a temporary time, that is going to be equal to this date minus the minimum date. And I'm going to append, let me call this times from the history, his times. I'm going to append every time I go through a loop, append this new date, temp time. Okay. We run this, going to add a new cell. Oops, what happened here? This date, sorry, this date. Okay, so this is printing, actually this is printing the minimum date. And if I show you what I have now, times underscore hist, I have all those time deltas. And in fact, what I can do is convert these to dot days. If I run that, and now I have a numerical values of the dates. And if you remember, we already produced the equation to perform the forecast, which is that equation that you have in there, which is this QMP. So if I borrow that equation, I'm going to call this Q forecast, or let's call it QFit. And I'm going to use the same function that I defined before, same rate that we defined last week, M and A coefficients as we defined it last week, but now I'm going to take the times history. Okay, divided by 0. Okay, so before I do that, because of the first value is 0, actually, the equation, we cannot provide a 0 value. What I'm going to do is replace that times his the first value. I'm going to replace it with 0.001. Okay. And now I should be able to run this equation. And if we go back, now let's build the whole plot again. We're going to be the plot again, but now we're going to also add, this equation that we added the other day. So, and this is going to be my final plot. So instead of dates corrected, I'm going to bring the times history and the well rates. And instead of QMP, I'm going to plot QFit, and I'm going to plot here my times history. So let's see how that plot looks like. Right, there we go. So, so far, this is fine. And what I asked you the other day was to play around with the numbers and almost feel a bit the pain of playing around with those numbers and find the fit. So if I bring all this together, I'm going to put this actually in here. And I'm going to just slightly fine-tune my QI to, let's say, 500. I'm going to leave my M and A coefficients as they are. So I can start to play around with this curve, and you may want to, depending on the information from the more technical information that you have from that well, such as a pressure or the artificial lift system that is used on the well, mechanical conditions and so on, you may decide whether you want to fit this part of a curve or you want to fit the whole curve. So let's say I'm just satisfied to fit slightly the last part of a curve, and I'm just going to produce something like this. So from that up to this point, I have shown you a few capabilities in terms of plotting. And you can see we can overlay multiple plots, and in fact, we can prepare this canvas to produce multiple plots visualization. And I have used a function, introduce NumPy, and also use this Duong equation to perform a fit on some historical data from this oil well producer. So let's take that now to the next level. So the next level is what is it that you would expect? Think about the power of Python, and thinking that you have now this foundation. Where do you want to take this now further?
Fit the curve.
You want to fit the curve. You don't want to play with the well as I am playing at the moment. Okay. What else?
Forecast.
Forecast. Yeah, that's a good one. I can take that curve, extend it few more years, and then understand how much we're able to produce from that well. What about doing this on as many wells as you have in the field? Yeah.
Yeah.
So I'm going to do three things, in fact, now for the next exercise. The first thing is fit the curve, as someone mentioned. And the second thing is I'm going to do it in quite a few more wells. And the third thing is I'm going to import the data from an Excel file. So those three new things, three new skills, and I'm going to introduce for that third skill the library pandas, okay, which is super important in all these topics to understand pandas. So what I'm going to do now is save. I think this is save. Let me save it. So up to this point, do you have any question, comments?
So far, so good.
Okay, so I'm going to create a new file, and going to bring it slightly from scratch. And in this case, let me copy from my exercise. This is text. So we've done the fit with one well before, which is in fact, let me put this this well number from the Vaca Muerta formation on conventional well, and now we want to bring 4 wells. And you will realize that once you bring 4 wells and you have the workflow for 2 or 3 or 4 wells, you can do the same with 1,000 of wells, and that's really the power of all this stuff that we're trying to do here. So so we want to we have seen already functions, so that's something that we have seen. We have seen opening. We haven't seen opening Excel files. We're going to see opening Excel files. We will see pandas data frame, and also storing data into panda data frame. We will use SciPy library to fit the equation, the dual equation. And let's try to do some more advanced stuff with Matplotlib. So let's bring the equation that we have here, the equation that the dual equation. So first of all, let me define the equation. We already have it. And so that's the first step that we have already done in the previous exercise. So we're defining that define one equation as a function or def. And now I'm going to open the file. And let me figure out just a second, where is that file? Give me 1 second. So there we go. There we go. So what I'm going to do here in my folders, in the sample data, where am I going to put it? Is it home here? Okay. I'm going to upload this file, Vaca Muerta for wells. Okay. Remind me, please, Rod, to give you this this file when we finish. So I don't know, but if I open and show you this this file, and show you what I have in the file.
Are you able to share the file right now, or?
I am able. I have some issues with the. I can send the file to Ro, and then she can send it to you. Is that okay, Ro?
Yep, that's fine.
Okay, let me do that.
Thank you.
No problem. So, okay, so we have these 4 wells, and we have some dates here. And we also have the columns with the production data from the wells. Let's try to look at the data. It's actually in the base tab or spreadsheet here. So I'm going to close this. And first thing that I would like to do when I'm importing data, it's of course exploring a bit the data. So I'm going to, by the way, leave a placeholder here for import libraries, and I'm going to import the libraries as we start to work on it. And I'm going to do more space here where I'm going to import and plot data. So what is can any one of you tell me what is a library that is used to read formatted tables into Python?
Pandas.
Okay, so pandas is the library that we will be using. So if you import pandas, and usually pandas is import with the nickname PD. So I'm going to import night pandas, and I believe that I can do PD dot, and I can read several type of files. In this case, I'm going to read an Excel, and in this case, I think I don't know how I can take this name here, but let me see if I can do home vaca muerta. X. And we want to bring it from the sheet name base. I don't think that's going to work. Let me see. Is that going to work? Yeah, it worked. Okay. So I'm actually reading straight away this, and I'm going to store it in something called, in whatever variable I want to call it for this scenario. I'm going to call it df, which is a usual variable name that you will see around, which is a data frame. And so if I store it in a data frame, I can do quite a few things with that data frame. And one thing that I like to do is to describe, describe. And with the data frame describe, I can see what I have in every column. In this case, it's a count of values for this well. For this column, I have this number of values, 34 values. This is a mean rate for the well, for every one of the well. This is a maximum rate, and that is a minimum rate. So I have a P25, P50, and P75 as well reported with the describe. And of course, we can do things like import matplotlib as pyplot as PLP. We can do that, and we can do the plot as we did it before. But matplotlib has also a function, a plotting function. I believe you can do df plot, and you can specify what you want to plot. So in this case, and just as a reminder, I can also, let's say, if I want to extract the first 3 values of the table, I'm going to put head 3. So I have the first 3 rows of the table. So I want to plot fecha data versus one well. I'm going to plot one well. See if that works. Right. So that works. It didn't only works, but actually what you will see here is that it's recognizing my dates as dates. So Panda was clever enough to recognize these numbers as and the corresponding dates. And this is because we're reading an Excel. Be careful when you're working with CSV files, because you may have a date in a different format, and you may have to do the tricks that I showed you before. But in this case, quite helpful. Pandas did the whole thing for us, and we didn't have to worry too much. So far so good. And you can imagine that I can do every plot. And if I want to do every plot, I'm going to try to do every plot in the most clever way, without writing the name of the wells here. And what I would do is first I'm going to do a plot where all the plots are overlaid, and then I'm going to do a plot where all the plots are going to be separate. So there's quite a few more things with, and for that I'm going to use matplotlib. So I'm going to use my for loop, and I want to do this for well in wells. And of course, I can copy the name of all these wells here, but that's not what I want to do, because that's going to be a lot of work if I have 1,000 wells. I can do df dot columns, and I can make a list out of that. And I can store the wells there. What's the problem with this? Is there a problem with this statement here? Let's see if we have a problem here.
Not really.
And we have a problem because we have the date, just in Spanish, fecha data. We have a date in the first item. Okay, so I can do, if I want to clean it, I can do wells is equal to wells, and I can do slicing of the list. So I can take from item 1 up to the end. This column means that I want all the items up to the end of the list. And let's see if that returns all the values. Oops, what's happening? List must be an integer. So it should be from 1. No, it should be fine. No, that's not right. Let's see, there is another one, but I can do wells up. I believe I can do 0. Let's see if that works. And if I do that, I won't have to do this. Yeah, that works as well. Right, so I have a list of the wells, and now I can do for welling wells, and I want to produce a plt.plot a EF. So what this is important. If I want to access a column, and let me put that example here. If I want to access information from a column, in this case, I want to access information from this well, I can simply write df, square brackets, and the name of the well. And then I have all those values here. And this is what is called a time series. This is not a list. Okay. So if I do a type of this, when I'm taking information from the pandas data frame, you will realize that, let me print this type. You will realize this is actually a pandas data series. And of course, I believe that you can always do something like toList if it's ever needed. And you will see that this is now a list. Okay, but let's leave it as a pandas data series for the time being. Okay, so I want to do df, and I want to bring the dates. And I want to bring the well. Because every time I'm iterating, remember that every time I'm iterating, I'm actually taking the name of a well from the list of wells, and now I can plot it. Of course, I have to put here df, and again, square bracket, and see that works. Oh, sorry, this is not, this is without the square bracket. Sorry, without the df well. So let's see the complaint here. Name type float is an invalid key. What what's happening there. Oh. There we go. So now I have all the plots, and I believe I can do something like a legend. Why is it not working? Penalty legend. Let me see the attributes on the PLT dot. Oh, misspelled. Sorry. Legend. And I think it's going to complain because I don't have a labels. So let me see. Well, it produced a plot. No handles with labels found to put in legend. And I think this is happening because I need to put the name of the actual well here. And let's see if that works. Yeah. So I put in the for every plot in the for loop, I'm adding the label of that plot, the label of that, in this case, of every line, and I am plotting the legend at the end. Right, so that was good. What if I want to produce independent and separate plots? What can I do?
Create subplots.
I can create subplots, but if I don't want to do something as giving them a format, it would suffice with stating for every plot, and I'm going to put for every plot, I will just simply type show. If I do that, so there we go. We have the four plots in independent canvases. Because what I'm stating is that as soon as this instance of matplotlib is created, plot that instance. So when the loop starts, it starts with a completely new canvas. And that's why I have a completely new plot here. Okay, so far so good. Any questions? No? Okay. There's quite a few things to do, and in fact, one thing that I'm going to do here, it's you can add, let's say you want to add different colors to those plots. So you can set your colors, and because I have 4 wells, I'm just going to type the colors that I want on those wells. I want this to be black, green, blue, and red. And then here on I can add an attribute color in the plot and add the color that I want. So, but how I can actually pass the right color here, because I want this to be iterative. So at the moment, if I put colors, this is a whole list. So if I run that, it's going to give me an error, because it's basically saying, well, you have an invalid color. You're giving me a list of something, but I actually need a red, green, blue, whatever array of colors. And that's not what you're providing here. So one thing that you can do is use one trick that is enumerate. So every time that you're going through the wells, you're going to count. You're going to make a count. So this is actually a quick way to produce a a counter. You're going to enumerate the wells, and you're going to store the number of the counter in the variable I. So now I can go into colors and call I. If I do that, now I have all those colors. Okay. Right. So SciPy, let's see how we are in terms of time. So we have imported the multiple wells, and we have made some plots. And what we really would like to do is fit that equation. And for that, I'm going to go to the top. As I mentioned, I like to import my libraries. I want to import my libraries in the top. And if you want to do use a curve fit within SciPy, there is a class called optimize with quite a few functions. In this case, you have in SciPy, you can import from SciPy optimize. You can import the curve fit function. Okay. And curve fit is a function where you will need to provide in this case, xy, and then all the coefficients. You need to provide the function that you want to optimize and all the coefficients of the functions that you may want to optimize. Okay, so let's see how much we can do. So, and let's talk about how this curve fit works. So, curve fit will take first the equation that you would like to optimize, and in this case, it's the Duong equation. And in this case, we want to predict for different. We want to predict dates. These dates here. So we can take the fecha data. In fact, this is not going to work as with these dates. We have to convert these dates to time, but for the timing, I'm going to do it like that. And let's say we want to optimize, let's take just one well, and I'm going to take this well. And as you remember Duong, that equation has time, qi, m, and a. Of course, time is the x-index, the x-axis. So we want is to evaluate for a series of x's. We want to produce a lot of rates and see if qi, m, how I need to modify qi, m, and a so I can fit the historical data. And something that I did here that I probably should have done better, and this should have been actually scattered data. I prefer to plot the, oops, what happened? So I prefer to plot the historical data with dots. Yeah. So we want to optimize this. We want to optimize and we want to fit these rates over this time by modifying the coefficients of the Duong equation. Usually when you use curve fit, you need to specify what are the initial values of your optimizer. In this case, let's say that for that well, I'm going to specify, it doesn't really matter, but let's say 1,000 barrels per day. 1,000, that's my first point. My first guess of m is 1.0, and my first guess of a is 1.0. And my bounds, and this is very important because you need to specify to the optimizer within which range it's going to operate. So I have to specify a couple of lists. The list with the lowest values of these three coefficients, and the list with the highest value of the same three coefficients. So I want the rate to go from 0, because otherwise the optimizer can go into negative values, can do wild things. So you want to keep everything restricted to what is physically possible in that equation. So this is going to be 0.0. It's going to be 0.0. And the top values, I'm going to say, well, maximum rate that a well can produce, a wild number is well can produce 50,000 barrels per day. I don't know anything about this, but I know that wells max may be able to produce that much. I'm going to put my M to 3 and my A to 0. Okay. For the example, as I mentioned, this is not going to work. Let me see if that works actually. Okay. Okay, this is trying to run this equation, but I have NP specified in the function, and I need to import NumPy in order to run that function. Okay. Now let's go to the bottom again and see if that works. Cannot perform power with this index, date time array. And this is why I was going to mention we cannot run this with the dates. We actually have to convert this to time. And the way to convert it to time, we saw that already before. I'm just going to copy a bit of the code to do it quicker here. Let's do it. Let's do it here. I'm going to leave the error here for you to remember. So this is a mean date. It's equal to mean of all the df in fecha data. And I'm going to do something. Let's keep doing it as it is. So now I want to add to the data frame. I want to add times. I want to add those times, and I'm going to add it straight away into the data frame. So I'm going to add it as a new column in the data frame, and I can do the date minus in date. If this works, okay, and it's useful to convert. If I show you now the f dot head, let's show five values in the header. You see that I have times, and by the way, this is not actually. I need to pass a float. I cannot use a date-time array. You need to pass a float. So I would need to convert these times to ET days. Okay, if I do that, oh, because I already converted that. Okay, let me run this. So you see that now this is actually float numbers. And as I mentioned before, I want this to have, I don't want this to be 0. And in fact, one thing that I'm going to do here, just for a quick illustration, and it's not ideas, but I'm going to add 0.0001. So all these states start from 0.001. Okay. Now let's copy this. And let's see if I now introduce times, what happens here? Okay, residuals are not finite at the initial point. And I'm not quite sure what's happening there. But what I'm going to do is going to leave you this exercise. This is going to be finished next week. Oh, sorry, or in a couple of days. And we will finish this exercise and we'll try to do another one of exploratory data analysis. But I'm going to right here try to fit all the wells and plot your best match. And just a bit of a challenge for this, I'm going to ask you to do something like this. Let me copy. Okay. Right. So
the issue is the zero. Like it's trying to divide by 0. That's why it's giving an error.
okay. So I'm going to yeah. Maybe some of the initialization points are too small. But I'm going to leave you to try to sort out this issue. And at the end, I would like to see if you can come up with something like this. Okay. So that will be my exercise 3. And I guess we will see you in a couple of days. I'm going to send you this row, and you have already the data for this one. If you can send to everyone, would be great.
Sounds good. Awesome.